of all the different methods you're going to learn in this course for measuring variation, the range is going to be the easiest by far. So the range is not only easy to calculate, which I'll show you in a moment, it's also very easy to understand. And that's not necessarily going to be true for the other methods that we use to measure variation. So the range is a nice starting place. Okay, so let's have a look at what the range is. The range has a simple formula. Actually, it might not look so simple right away. I'll write it out like this. It's the range is equals to the maximum x value that you might have, so the maximum raw score, the highest raw score, minus the minimum of your raw scores. So let's just do a really simple example. Let's say I ask people, a group of parents, what's the age of your oldest child? And so the first person says their oldest child is only 1, and the next person says 3, and the last person, just a really small sample here, says 9 years old. Okay, so we've got 3 different values. They're in order here. This one is my minimum, so that is my minimum x. Here is my maximum. And so if I wanted to find the range of ages that I'm dealing with in this sample, then I would simply just do 9 minus 1, and that's equals to 8. And so what I'm saying is that the range of ages covered here in this sample is 8 years, which was super easy to calculate. I just do 9 minus 1, my maximum minus my minimum. Couldn't be any easier to find a maximum and a minimum value. I mean, that's about the easiest formula you're going to be dealing with in this course. And I just subtract the lower one from the higher one. And so what I have is an answer that's also easy to understand. It just gives me a really intuitive idea of how to measure how spread out a distribution is. Just literally look at where it begins, where it ends, and find the distance between those 2 points. Initially, this might get a little bit more complicated if we do something like, let's say if we're dealing with continuous data. So let me just give an extra example. Continuous, I think I've spelled that right. For continuous data, I'm going to be looking at, make a bit of space here, the range being set up as the maximum, but I have to take the upper real limit. So actually, let me go back a little bit. The upper real limit of the maximum minus the lower real limit of the minimum. Okay, so what would that be? Well, we're going to have a different sort of scenario here. Our data is going to look something like this. Let me try, let's say we've got a few people are giving us how much they weigh. And so somebody weighs 148 pounds, and somebody else weighs 152 pounds, 158 pounds, and then there's somebody who's 165 pounds. Okay, so any kind of a measurement is going to be continuous data. We dealt with this in an earlier video. So if I have a measurement, that's automatically continuous data. So my measurements here, I've got my minimum measurement and I've got my maximum measurement. But I'm not just going to do 165 minus 148. Instead, I have to do the upper real limit of 165. And so that just means a half step above. So that's going to be 165.5 minus a half step below, because it's the lower real limit of this. 148, if I'm working out my real limits, has a lower real limit a half step below, so that's 147.5, and an upper real limit of 148.5. And so I'm going to do the lower real limit because that's what it calls for here. It's 147.5. All right, so when I work out the range now, I've got 165.5 minus 147.5, and that comes out to be an even 18. But that's still not very complicated. Including the real limits just comes down to knowing when you're dealing with continuous data. But essentially, the range is just the highest minus the lowest value in your data set. So why bother using other measures? I mean, this is about as simple as it can be, and it's also easy to understand what our answers are. Like this 18 here, it means that there is a range between the heaviest and the lightest person of 18 pounds. So nice and simple, easy to understand. This is the sort of thing that we use in real life all the time, in common language all the time. Well, here's where the problem comes in. Let me make a bit of space here. The range has one really big flaw. It only takes into account the two scores at either end of the distribution. Okay, so let's say I have two sets of data. I've got one set of data where the values are 1, 2, 3, 4, 5, 6, and I have another set of data where the values are 1, 3, 3, 3, 3, 6. Okay, now have a look at what my minimum value is here. Oops. It's the same over here. My maximum value, I'll call this sample A, and this is sample B. My maximum value is a 6 in sample A. It's also a 6 in sample B. So they both have the same minimum. They both have the same maximum. If it was continuous data and I did the real limit, they would both have the same lower real limit of the minimum, and they would both have the same higher real limit of the maximum. So as far as range is concerned, both of these groups would end up having the same measure of variation. The range here would be 6 minus 1 equals to 5. The range in group B would be 6 minus 1 equals to 5. But that would be like saying that they both have exactly the same amount of variation. Now that's not quite true. It's true that they do have the same range, but look over here at A. If we were to draw out this distribution, it would look something like this. Actually it wouldn't look something like this, it would look exactly like this. We've got 1, 2, 3, 4, 5, 6. These are our values, and then the frequencies on the side, we have just one of each of these values. So it would be an evenly spread out distribution. So we'd have these 6 blocks spread out like this. Whereas for B, it's going to be a bit different. We're going to have, again, 1, 2, 3, 4, 5, 6. But we have something different happening here. We do have a value of 1, and we have the upper, or the maximum value of 6, but then the rest of the distribution is all clustered around the center. And that's not really what a large amount of variation means. Here I have more of an even spread. Here, things are clustered in towards the center. This one has less variation, whereas over here I can see that I have more variation. Why would being evenly spread out be more variation? Well, think about it. Let's get away from numbers and think about it this way. Actually, let's keep that available. Imagine that you work for the government and you've been sent to a company to have a look and see whether or not they have any racial bias in their hiring practices. And so you do notice that there are some people at the company that are Asian and some people that are African, and some people that are Caucasian. Now, having some of each group doesn't necessarily mean that you have a diversity amongst your employees, that you have a lot of variation amongst your employees. I mean, this certainly looks like hiring practices are not too biased. But what if, let's call that company A, what if at company B you saw this? You had one Asian and one person of African descent, and then you had 380 people that were Caucasian. Now, there is an Asian person, an African person, and there is more than one Caucasian person, but you've got somebody from each group. You certainly don't have as much variation here because everything is clustered in this one category. That's the same as what we're seeing up here. The majority of our data is clustered right around the 3. This means that there is less variation. When things cluster up towards the center, it's not as spread out. Here, things are more spread out. There's more variation. The range fails to notice that. The range fails to notice that basically because the range ignores everything that happens inside of a distribution. It only cares about the minimum and maximum values. And so for that reason, it's not considered to be a very appropriate measure of variation within statistics because it's ignoring most of the data. In fact, here we have very small data sets. So by having the minimum and the maximum taken into account, by paying attention to those, we're still dealing with a lot of the distribution. We're still dealing with a fairly large amount of the sample because that's about a third of the sample, I think. But most samples are going to be hundreds of people or thousands of people. If you're only looking at the two extremes, the extremely low and the extremely high values, you're ignoring the majority of your data. So that's not a very appropriate way to deal with all of the data that you've collected. Ideally, we want to have a way to measure variation that takes into account every single value of data that has gone into our study. So for this reason, the range is typically not used. It's not considered to be an accurate measure of the spread of a distribution. That being said, though, if you ever do get an opportunity to use the range, the formula is about as simple as can be. So it's a bit unfortunate that you won't see much more of it in the course, but at least for now, while you're being tested on this chapter, it's a very easy way to get some easy marks, and it's also it gives an easy result to understand.